Because we had the fire drill, my first period got a little further along than my third period, so I am going to start this video from reflections. We're going to look at three different kinds of reflections. If we simply negate the entire function, so we'd be looking at y equals negative f of x, that's going to be a reflection across the x-axis. And let's go ahead and focus on this one first. So in this problem we have f of x equals x cubed minus 2x squared minus 5x plus 6. If we look at negative f of x, that's going to negate everything in that function. And so that is all written down here. We have negative x cubed plus 2x squared plus 5x minus 6. Now what we're going to do is we're going to go into our graphing calculators and we're going to put those in just like that. So we're going to put in x cubed, and be sure you arrow out of that exponent, minus 2x squared minus 5x plus 6. And we're going to compare that to its opposite, which is going to be negative x cubed plus 2x squared plus 5x minus 6. Now when we graph these, our blue one will be our first graph that comes up, and that's y sub 1, that's our original function. And then the red one that's going to come up right now should show a perfect reflection over the x-axis. So that's our negative f of x. Now let's go look at our f of negative x. And when we do f of negative x, we plug in negative x everywhere, we end up getting negative x cubed minus 2x squared plus 5x plus 6. So now let's go back into our calculators, and we're going to put this one under y sub 3, but we don't want to see all of these graphs on here at once. So as you go to y sub 2, go over and highlight the equal sign and hit enter. What that's going to do is it's going to stop showing that graph for now, unless you select it again. So f of negative x is negative x cubed minus 2x squared plus 5x plus 6. So this one should show a reflection of our original graph, but this time the reflection is going to be over the y-axis. So if we folded that blue function over the y-axis, it would become what that black function is right there. So now let's look at our third type of reflection, and that's when we negate everything. And so we're looking at, in this case, negative f of negative x. And all we're going to do is negate everything that we just had. So looking up at our purple function right there, we're going to have positive x cubed plus 2x squared minus 5x minus 6. So let's go back into our graphing calculators and into y equals. This time I'm going to be sure to unselect y sub 3. And I'm going to scroll down to y sub 4 and put in x cubed plus 2x squared minus 5x minus 6. And so this time it says that it's through the origin. That means it's basically rotated 180 degrees about the origin. So there's our original function again. And there's our rotation. If we flipped this whole graph upside down, it would look like the purple. So those are the three types of reflections you're going to see: across the x-axis, across the y-axis, and through the origin. So let's go on to our vertical stretches and shrinks. And this is the first time we're actually going to change the shape of our parent function. So we're going to do what are called dilations in this case. And so let's start with sine of x, and let me do a review on how we get our basic parent function for sine of x. Continue. So a quick review from last year, if we look at how to just graph this parent function, if you remember, we have x and we have sine of x. So when x equals 0, sine of 0 is also equal to 0. And last year, I remember I told my class the sine function starts out as a frowny face and then it goes into a smiley face, and it has a period of 2 pi. So we're going to pick our major points in between there. We have 0, pi, and 2 pi, all of which is where sine is going to be equal to 0. And then we have pi over 2, and at pi over 2, sine of x is equal to 1. And then we have 3 pi over 2. And at 3 pi over 2, sine is equal to -1. And so this is showing one period of the sine function. And if you remember, it oscillates between going up to 1 and down to -1. And so if I put my points on here, 2 pi is going to be equal to 6.28, so it's going to be 0 there. 3.14, it's going to be 0 there, and it's 0, 0. Now at half of pi, so right around here, it's going to go up to 1. And then between pi and 2 pi, it's going to go down to -1. So here's one period of our sine function, frowny face and then smiley face. Now let's look at this in our graphing calculators and see what happens when we put in 3 sine of x. So we're going to clear out all of our functions from last time. And let's just put in our simple sine of x. And this is showing more than one period. I just showed one period. I don't remember exactly what the last thing I said was. The bell rang 45 minutes ago, so I've had a big break since then. But now what we're going to do is we're actually going to look at this sine function, this period of a sine function, and we're going to look at 3 times sine of x, and we're going to show that on this graph as well. Now all that's happening when we do 3 times sine of x is, hold on, I want out of there, I want my pen back. So 3 sine of x, all that's doing is multiplying all of these values by 3. So the output's still 0 there, 3 there, 0 here, -3 here, and 0 here. And so our maximums are now going up to 3 and down to -3, and it's going like this. So we've just vertically stretched our function by just multiplying it by 3 on the front. Now let's look at what happens if we multiply this very same function by 1/2. So we're going to put 1/2 sine x over in this column. It's not really wanting me to do that. So we're going to look back at our original sine outputs, which are here, and multiply by 1/2. So now we're going to get 0, 1/2, 0, -1/2. I don't know why it's doing that. Stop moving it. And then 0. So sorry that looks awful, but we have 0, 1/2, 0, -1/2, and then 0. So when we multiplied by 1/2, we now squished it, and so we shrank it vertically by multiplying by a number that was between 0 and 1. If we multiply, so this shrinks vertically, and this stretches vertically. I don't know why this is doing this. Stretches vertically if our multiplier is greater than 1. So this is our dilator. We've now changed the shape of our function by multiplying it by something. So going on to cosine of x. Now cosine, if we remember from last year, so we have x and cosine of x. And again, our period is going to go from 0 to 2 pi. Pi will be in the very middle of the period. And then we have pi over 2 and 3 pi over 2. So cosine when x equals 0 is 1. At pi over 2 it's 0. At pi it's negative 1. At 3 pi over 2 it's 0. And then at 2 pi we're back at 1. So cosine is our little smiley face. So pi, 0, pi, and 2 pi. Sorry, that should be slightly over here. And then halfway between here and halfway between here. And cosine is our smirk. One period of a one period of a cosine function just looks like a little smirky face. Apparently I'm having issues. Now let's look at what happens, because the period in a cosine function is represented right here. And when we just have cosine of x, we're looking at a period of 2 pi. Now let's look at what happens when we graph g of x, where we now have a period listed as 2x. So we're saying basically 2x equals our period, which is 2 pi. And so now what we're getting is that x equals pi. What does that mean? Well, that means that the entire cosine function is now taking place in the period of pi instead of 2 pi. And so what happens here, and let's do this one on our graphing calculators. This can be a little easier to see. So let's go ahead and clear this out and put in cosine of x. And then on y sub 2, let's put in cosine of 2x. And graph it. So there's our regular cosine function, and every 2 pi it's going through one period. And now we just changed it. So that now our period is pi over 2. And so now when you look at the red and you see one full smiley face going from here to here, that's pi. We're going from 0 to pi, and then we're going from pi to 2 pi. But if you compare that to the blue one period was from 0 to 2 pi. And so this compressed our function horizontally. And so it squeezed it. And that's when c is greater than 1. So it's kind of the opposite of what you would think. When c is greater than 1, it is compressing it horizontally. I misspelled compressing. So it didn't change anything about our max and mins. Oh, I should change to red. But it did make our function, I can't draw, go 2 times in the 2 pi period. So now let's look at cosine of 1/2 x. So again, now we've taken our 2 pi period and we're setting it equal to 1/2 x. So 2 pi equals 1/2 x. And when I solve for x, we get that now the cosine function is happening over a period of 4 pi. So this is really stretching it horizontally. And if we look at this in our graphing calculator, let's go ahead and make y sub 3 cosine of 1/2 x. And it's a little bit hard because this calculator isn't even showing the full period if we started at 0. Because here we have 0 and we go all the way and we see 2 pi is right here. That's where our blue one ended. And then this is only going out to 10. We would need to have it go out a little bit past 12 to see this full function. So I'm actually going to change my window, and I'm going to make my x maximum go to 2 pi because I can. I can hit 2 pi. So this should show, and I'm going to make my x minimum go to negative 2 pi. Oops. I have to hit second pi. And I'm going to make my range go to y minimum of negative 4 and y maximum of 4, just to see it a little bit better. So now this should show exactly one period of the black cosine of 1/2 x, because I'm showing from negative 2 pi to positive 2 pi, so this is going to show a 4 pi period. So let's see, we have and even though it's not showing the exact smirk, this is one period of it. If I had chosen to show it from negative pi up to 3 pi, you would get more of a smirk, or if I had chosen to show it from 0 to 4 pi, you would see the total smirk. As a matter of fact, let's do that. So let's make our x minimum go from 0 and our x maximum go to 4 pi. And now you're going to see exactly one period of the black cosine 1/2 x function. So here's one period of the blue, 2 periods of the cosine x, 1 period of cosine 2x, another period, another period. Now we have our cosine of 1/2 x going from 0 to 4 pi. So if 0 is less than c is less than 1, that's compressing all of our functions horizontal. I mean, it's stretching all of our functions horizontally. And that's it. This should help you to do your homework.